Live? Are we live? Let me wait for some time. It's connecting, I guess. Are we live? Yeah, I think we are live already. Okay. Now, basically, in this video, we will try to solve all the problems of MIT integration by 2024 regular season. Yeah. So basically, after qualifier exam, we have regular season, quarterfinals, semi-finals, and finals. And in this video, we will try to solve all the problems of regular season. Basically, there are 20 problems. Yeah, so as you can see over here in this PDF. So we will try to solve all of these problems in this video. Yeah. So are any of you connected with me? Okay, not anyone till now. But yeah, I think like soon we will have some viewers. So let's begin solving the problems. Okay. And the time for each integral is 2 minutes, but basically we will take some long time to solve these problems. Let's begin with the first problem. Yeah. The first problem is like this. This problem involves g function. Yeah. So basically g function returns the greatest integer less than x. Yeah. So basically if we have to find g of 2.6, the greatest integer less than 2.6 is 2, so this will be the answer. Yeah, so basically now if we are taking log 43 of x and then g, so basically until x reaches 43, so basically if it's just 42, then in that case also there is something like 1.0.99 something like that. If we take g of this, we will just get 0. So basically up to 42 the value of the integrand will just be 0, so there will be no integral that we need to evaluate. But from 43 to 43 square, we will just get 1 as the value of the g function. Yeah, so basically from 43 to 43 square we get 1, and from 43 square to 43 cube, so basically this number is less than 43 cube. Okay, so up to 24, let us say, we will get 2. Yeah, because if it's 43 we point and something greater than it's this, let's say 43 square plus 1, then we will just get 1.001 something like that, and this will also be 1. Yeah, that's why for this, sorry, not 1, 2.001. Yeah, so this will be 2. So that's why now let us find 43 square first. 43 square is 1849. Yeah, so basically x from 43 to 1849 and 2x from 1849 to 2024. So that's why from this we will have 1806. Over here we will have 2 times 9, 5, 14, 7 and 1. Yeah, that's why 1806 plus 0, 5, 3. So, and we have 56, 1, 2, 2156 as the answer. Yeah, let us check if that's the answer or not. Yeah, 2156 is the answer. Yeah. Okay, Sandeep Paul, I hope you are enjoying these integrals. Yeah. Now let's go to next problem. Okay. Now in this problem, we are given this integral. Yeah. Now basically, what you can observe in this problem is, if you take x to the power 2024 common out, you will have 1 minus x to the power 2023. Yeah. So that's why what you can do is you can let y as x to the power minus 2023, because if you do that, this term over here x to the power 2024 will be included in the differential element itself, and that will help us make the problem easier, because that makes the problem like this. Yeah, now if this is the new problem, our problem is easier, because now our problem is dy by minus 2023 by this is 1 minus just y inverse. Yeah, so now it will not be that hard. Minus 1 by 2023, and this is y by y minus 1 dy. Now we have minus 1 by 2023 integral going from y minus 1 plus 1 by y minus 1 dy, which is why we have minus 1 by 2023 integral of 1 plus 1 by y minus 1 dy. Okay, so now we can easily solve this. Yeah, minus 1 by 2023, and then we have y plus ln of y minus 1. Now we know what y is. Yeah, y is just x to the power minus 2023, isn't it? So that's why we can say that minus 1 by 2023 and then x to the power minus 2023 plus ln of x to the power minus 2023 minus 1 plus c, don't forget that, plus c. And now this is minus 1 by 2023, and over here we have 1 by x to the power 2023 plus ln of 1 minus x to the power 2023, and then in denominator we have x to the power 2023. Yeah, so minus 2023 ln of x. Yeah, and then plus c. So now we just distribute this expression for all of them, and then we get ln of x. Yeah, from here it will minus sign and the number will just cancel out. Over here we have minus 1 by 2023. Yeah, and then x to the power minus 2023. Over here we have minus 1 by 2023 ln of 1 minus x to the power 2023 plus c. So this is the answer. Let us check the answer if it's correct or not. Yeah, okay. Yeah, so basically ln of x minus 1 by 2023 log of 1 minus x to the power 2023. Yeah, and then 1 by minus 2023 x to the power minus 2023. Yeah, so that's correct. Yeah, okay, so basically Sandeep Paudel is there, he's using these integrals, I guess. Let's move to next problem. Regular season problem 3. Okay, so for this problem we can basically use King's rule. Yeah, basically King's rule states that if integral is from 0 a to b and f of x dx, in that case what you can do is this integral is also equals to f of a plus b minus x dx. To see why this is true, just integrate both of these functions and check the final result. Those will be same. Or I also have a video on my channel. Yeah, so basically on a playlist where named Introduction to Some Slightly Advanced Mathematical Techniques. In that playlist I do have videos like explaining the geometric interpretation and other meanings of this. Now if we use that, over here we have integral from 0 to 1. This is 1 minus x whole square, and over here we have 1 minus sorry 1 minus x to the power 2024 dx. So we have integral from 0 to 1, 1 minus x whole square. This is just x to the power 2024 dx. Okay, so now the next thing that we can do is to expand this. So we have integral from 0 to 1, 1 minus 2x plus x square, and then x to the power 2024 dx. Now we have integral from 0 to 1. This can be written as x to the power 2024 minus 2 times x to the power 2025 plus x to the power 2026. Yeah, and then dx. Okay, now integrating this is a piece of cake. Yeah, it's not a great trouble to solve these sort of integrals if you can solve diagonal functions. Okay, minus 2 x to the power 2026 by 2026 plus x to the power 2027 by 2027 plus c. This is the answer. Oh yeah, let us check. You can also make this cancellation 1013. Let us check if this is the answer or not. Oh, okay, it asks for a definite integral. Yeah, I'm sorry for that. Now, okay, don't let us not cancel this if it's a definite integral, and this should go from 0 to 1. Yeah. Now for that, this will be 1 by 2025 minus 2 by 2026 plus, now this will be 1 by 2027. Yeah, and then plus c. Let me write it for plus c as well. Now minus 0 minus 0 plus 0 plus c. The plus c cancels out. Yeah, now we have to evaluate this. Yeah, we can basically evaluate this on our own as well without calculator. Let us see how. 2025 into 2026 into 2027. Now over here I will have 2026 into 2027. Yeah, and minus 2 times 2025 into 2027. Yeah, and over here I have 2025 into 2026. Yeah, now the next thing that I can do is to add these two things. Okay, so basically I get the 2026 common, and then if I add this to 2027 and 2025, what will I get? I will get 2 times 2026. Yeah, minus 2 times 2025 into 2027. Sorry for that. 2027. Yeah. Yeah. Now we have 2025 into 2026 into 2027. Now this is 2026 plus 1, 2026 minus 1. So you know what that is. Yeah. This is 2 into 2026 square minus this is 2026 square minus 1 square. Yeah. So now I think you have got what the answer is. No, it's not that hard. It feels like I'm doing like primary mathematics which involves numbers only, because when you go higher there aren't any numbers that are involved in your calculations. But since I'm dealing with numbers, it really feels like I'm doing some intro maths, something like that. 2027. And yeah, this is the answer. Let's check if that is the answer or not. Yeah. Okay, so basically there's one like. Okay, that's good, that's good. We should keep motivations. Okay, now let's go with this problem. Regular season problem 4. Yeah. Okay, now in this problem is really easy because if we break it into two terms, yeah, then that is just some high school calculus stuff. Yeah. Now after breaking, we can notice that over here, if I take x square plus 1025 as y, we have 2x dx as dy. So here's already x dx. So that's not a problem. Basically, what I can do is I can take 2023 by 2. Then we have a 2x dx is the derivative. So that's why this is 2023 by 2 ln of x square plus 2024. Now over here I have 1 by root under 2024, and this is tan inverse x by root 2024 plus c. Yeah, and this is the answer. Let's check. Yeah, 2023 by 2 ln x of 2024 plus 1 by 2024. Yeah, that's the answer, and it's the correct one. Now let's go to the next problem. Okay. Let me cancel this. Can I just close this one? Okay. Wait a second. I will just okay, now it's working. Sorry for that. Now let's get back to problem solving. Okay, now for this problem we can change this into tan and something, and so sec square x will be just derivative. So we have integral from 0 to pi by 2. This is, we know that sec square theta minus tan square theta equals to 1. Yeah, that's why sec square theta equals to 1 plus tan square theta minus of 1 plus tan square theta. Yeah, and then sec square theta d theta. Now if I let y as tan theta, this will be integral going from 0 to infinity. Yeah, e to the power minus 1 plus y square, and this will be dy. Okay, so now e to the power minus 1 is just constant that can be taken out, and I have integral from 0 to infinity e to the power minus y square di, which is a famous Gaussian integral whose answer is root. That's why this integral evaluates to root pi by 2e. What a nice answer. Yeah. Now let's check if the answer is correct or not. Root pi by 2. Yeah, that's correct. Basically today there aren't really many viewers, but no problem, we can solve integrals. We love solving integrals. It doesn't really matter. We love solving integrals. We are the calculus lovers. Yeah, we are the calculus lovers, bro. Now let's solve this. We have cos x by sin x. Now over here we have cos 2x by sin 2x dx. Yeah. Now the next thing we can do is to change this into simpler cos and sin forms. Cos x by sin x, and then cos square x minus sin square x by 2 sin x cos x dx. Now the cos cancels out. I can take 1 by 2 outside and then divide these expressions by sin square x. That gives me cot square x minus 1 dx. Now we know that cosec square theta minus cot square theta is equals to 1. That's why we will have cosec square theta minus 1 is equals to cot square theta. So we can say that this integral is actually equals to cosec square theta minus 2. Oh, not theta, x, and then dx. Now we know these are some pretty standard integrals. This is minus cot x and this is minus 2x. So we have the answer now. Yeah, let's check if this is correct or not. Yeah, so the answer is basically right. I can write this as minus x minus cot x by 2. Yeah, and plus c. That's the answer. Yeah. Oh, I'm here though. Oh, nice. Nice to see him answer. And we are solving problems from regular season of MIT Industry 2024. And these problems are really awesome. Yeah. So basically, one of the problems, problem 10 is really awesome. And we will slowly reach over there as well. Now let's solve this problem. So for this problem, what we can do is we can just break tan hx into sine and cos, and then it will simplify a lot. So we have sin h square x by sin h2x and then cos h2x. Yeah. And now we can just break them from their formulas of sin h2x and cos h2x. Yeah. Formula for cos h2x is cos h square x plus sin h square x. And to get these formulas, you can basically use the Osborne's rule. Yeah, you can use the Osborne's rule. And basically, from the trigonometric formulas, if we use Osborne's rule, we get the hyperbolic formulas. You can search about this, yeah, if you are interested. Now after this, we have 2 sin hx cos hx. Yeah, and then dx. Okay, so now sin hx gets cancelled. Yeah, and like what are we left with? We have 1 by 2, and then we have sin hx sec hx, and then cos h square x plus sin h square x dx. Okay, so now what can be our next step? Basically, if we merge these two, if we multiply, we have sin hx cos hx, yeah, and then dx. And what if we merge these two? We will have sin h square x by cos h square x, cos hx. Sorry, sin h cube x, not sin h square x. Now I think you can see the solution, like how do we solve this. Basically after this, there's nothing much to do. This one is sin h 2x by 2, yeah, so that's why its integral will be cos h 2x by 2 into 2. And over here, this is actually, we can write this as, because cos h square x minus sin h square x is equals to 1, we can write this as cos h square x minus 1, yeah, and then by cos hx and then sin hx dx. Now we can see like how this will be solved. Yeah, now this is 1 by 2 and then cos as 2x by 4. Over here, this will just be y square minus 1 by y, and this one will be dy. So basically, if we let y equals to cos x, we will get this thing, and now it's a piece of cake. Yeah, 1 by 2 cos 2x by 4 plus over here we had y, that's why y square by 2 cos x square by 2. Over here we will have 1 by y, that's why ln of y, ln of cos x. Let's see. Now basically what you can do is the answer is something different, I know that, because cos 2x by 2 is there, I guess. Yeah, so cos 2x by 4 minus 1 by 2 log cos x. Yeah, answer is this thing, but we don't really have that answer right now, but we can have that answer because we know that cos square x plus sin square x, this is cos 2x. Yeah, so you can use this property. So now after this, basically if you want to change this to cos 2x, what we can use is corresponding to the 1 plus cos 2x equals to 2 cos square x, we also have a formula 1 plus cos 2x equals to 2 cos square x. Yeah, so now what we can do is we can basically introduce a constant over here, cos square x by 2, and then okay, so I can make it 4 and then over here 2. Now introduce a minus 1, I can introduce a minus 1 by 4 because why I can do this is I will just change the constant of integration to c dash. Basically c is minus 1 by 4 plus c dash. Yeah, it doesn't matter what constant I give, and then we get 1 by 2. Now we know that this is cos 2x by 4. Over here also we have cos 2x by 4. Yeah, because cos 2x is 2 cos square 2, this is cos 2 cos square x minus 1. Yeah, that's why cos 2x by 4 minus ln of cos x plus c dash. Now what we can do, now we can add these two, so we have 1 by 2 and we have cos 2x by 2 minus ln of cos x plus c dash. So now finally if we distribute the half to both the terms, we get cos 2x by 4 minus ln of cos x by 2 plus c dash, and that is the answer. Let us check the answer. Yeah, that's the answer. Okay, so hope you guys are enjoying the solution, and let us proceed forward. Yeah, now the next problem, this one is also a pretty easy problem. You just have to use the integration by parts. So basically, like, because I'm here after solving these problems, I'm saying that these are easy, but in the first try they may or may not be. I'm not really sure. Okay, so basically for this we will take 1 as v and this as u and use integration by parts. So basically we will have tan inverse of root x, integral of 1 is just x minus integral of, now derivative of this is 1 by 1 plus x square. Yeah, and then we also have root x over here, so that's why we will have 1 by 2 root x. Integral of 1 is just x dx. Now we have x tan inverse root x minus 1 by 2. This is just root x by 1 plus x dx. Now to solve this we can make a substitution that y is root x. Yeah, let's try to solve this with that substitution. We have x tan inverse root x minus 1 by 2 over here, y by 1 plus y square, and then dx will be So basically y square equals to x, so dx will be 2y dy. Yeah. Now okay, wait a second. Let me, okay, now we have x tan inverse x root x. Yeah. And then this 2 cancel out, so we have minus of, now we can introduce a plus 1 and minus 1 so that this cancels the denominator, and now we have the answer x tan inverse root x, sorry, minus, this is just y, so that's root x, plus this is tan inverse y, so that's tan inverse root x, plus c. Now we can take tan inverse root x as common for the two terms, and then write over here x plus 1 minus root x plus c. This is the answer. You can check the answer basically. If you check the answer, you will get the answer to be like this, which is the same as what I derived. Yeah. Hope you are enjoying these solutions. Let's go to next problem. Okay, so if you try to solve this problem to get an answer, you have to use basically gamma functions, and gamma function you will get, and then you have to differentiate both the sides of the answer. Basically you can make a new integral. Yeah, you can make a new integral. Let me show it in the okay. So basically if you want to directly solve this problem, what you can do is you can basically take an integral from 0 to infinity of x to the power t by 1 plus x to the power 4 dx. Yeah. Now if we differentiate this, we will just have integral from 0 to infinity of x to the power t times ln of x by 1 plus x to the power 4 dx, and by differentiating I mean with respect to t. Yeah. So if you have the answer for this integral, and then you can differentiate that answer and also get an answer for this integral. Now substitute t equals to 0 and get the answer. Sorry, t equals to 1 and get the answer. But I did that, and if we do that, we do get an answer in a somehow complicated form. But like that's not intended for the ambiguous integration B. What you can instead do for this problem is you can make a substitution y equals to 1 by x. That gives the integral from infinity to 0, and this will be 1 by x, and then minus log x. This will be x to the power 4 plus 1 and times x to the power 4 over here. Now minus 1 by x square dx. Okay, so now we can see that in denominator we have x and x square, and over here that's x to the power 4. So the minus minus cancel out. We have integral from infinity to 0, and what do we have else? So basically these two terms cancel out with this to give x log x by 1 plus x to the power 4 dx. Now we know this is just minus of integral from 0 to infinity of x log x by 1 plus x to the power 4 dx. We know this is minus I. So what we are getting over here is I equals to minus I. That means 2I equals to 0. That means I equals to 0. And this was the solution for this problem. Yeah. Basically, if there are such complicated functions, you can directly guess that the answer is 0, because in 2 minutes you cannot really solve those problems. Yeah, that's why. Let's go to next problem now. I guess the answer is 0. Okay, so this problem is a pretty nice problem because it does take some time, because you need to make observations, something like that. And I wonder, like, how do they solve these problems in just 2 minutes? Yeah. Maybe there are alternatives. If there are, you can suggest me those alternatives. Yeah. So basically, when there are g functions, what we can do is we can basically break this integral. So what I can do is I can take a sum from n equals to 0 to 9, and then let the integral go from n to n plus 1. That way the integral goes from 0 to 1 plus 1 to 2 plus 2 to 3 plus 3 to 4 and so on. Basically it goes from 0 to 10 itself. So that is a good approach. Now we have x times g of x is just n, because n is the lowest, I mean greatest integer less than x, and dx. Yeah. Now what else can we do? We can make a substitution that y equals to nx, because that will simplify the thing that's here in the GIF, and that will give us dy by n equals to dx. So we have sum going from n equals to 0 to 9, integral going from n to n plus 1. This is GIF of y, and then dx is dy by n. Now since this n is just a constant, we can take it outside. N equals to 0 to 9, 1 by n, integral from n to n plus 1, GIF of y, and then dy. Yeah. So we need to evaluate this sum over here, and this does need some sort of observation if we are going by the technique that I am sharing. So let us see what happens when n equals to 0. In that case, the integral goes from 0 to, okay, so wait a second. So basically, because we have made y equals to nx, the limits of integral will also change. Basically we have n times n plus 1 times m. I forgot that. So over here n plus 1 times n, and over here n square. I'm sorry for that. Now the limits will go from 0 to 0. Yeah, that's why this will be 0, no doubt. Now when n equals to 1, yeah, so we have 1 by 1 times integral going from 1 to 2 of GIF of y dy. Yeah. Now we have 1 by 1 times, so when it's going from 1 to 2, in between the only value that it can, for any value like 1.5, 1.6, the GIF will just be 1. That's why since the width, okay, so basically GIF of y possesses the value 1 just for the interval 1. Yeah, so basically GIF of y possesses the value 1 for the interval from 1 to 2. The length of this interval is just 1, so that's why our answer will be 1 into 1, that is 1. Let's go to the next case when n equals to 2. We are not going to do all of them, yeah, but we will do some of them to find a pattern. Now this is from 4 to 6, yeah, and then we have GIF of y dy. Now in this, for the length, for the interval of 1, from 4 to 5, the value will be 4. Yeah, for 4.2, 4.3, that value will be 4. For the next interval from 5 to 6, the value will be 5. So we have 4 into 1 plus 4 into 1 plus 5 into 1. So basically the average of 4 plus 5 by 2, that's 4.5. Okay. Now let's do it over here. Okay, when n equals to 3, we basically have 1 by 3 of integral from 9 to 12, GIF of y dy. This is also same. For the interval of 1 from 9 to 10, we have the value as 9. For the interval of 1, we have 10, and for the interval of 1, we have 11. So basically, the average of 9 and 11 is just 10. Yeah. Basically, we are finding the average over here. For n equals to 4, we have 1 by 4, interval from 16 to 20, I guess. Yeah. GIF of y dy. Now this is just average of okay. So this is just average of the 16, 17, 18, 19. Yeah, and then 1 by 4, their average will be 17.5. Yeah. Now you should notice something. So basically the sum will be like trying to increase quadratically, but the values over here is increasing linearly. That's why these values will also increase. Okay, I'm not sure of that though. These values can increase both. Anyway, let's see how they will increase. Yeah. Now from 1 we have 4.5. That's by 3.5. Over here. Okay, that's by 3.5. Here 5.5. Here 7.5. Yeah. So you can see this is by increase by 3.5, and over here this is by 5.5. This is by 7.5. That's why the next will be by 9.5. Yeah. Okay, so that's why per n equals to 5, we will have 17.5 plus 9.5. That is, how much is that? 18 plus 9 is 27. Yeah. And then our next thing will be for n equals to 6, we will add 11.5. That's why we have 38.5. And then for n equals to 7, we will add 13.5. So 13.5 is it? 8, 9, 10, 11, 12, 13.5. Yeah. And then what should we have? If 13.5, 39, 40, 40 and 42, 52. Yeah. Okay, so that's 52. Yeah. Now basically I made an error in my copy, that's why I was confused. Okay. Now after this we add 15.5. Yeah, that's why per n equals to 8, we get 67.5. Per n equals to 9, we add 17.5. That's why we have 85. Now since there is a sum for all n's, we just have to add all of them. Now if I add 1, 3.5, 10, 10, no sorry, 1, 4.5, 10, 17.5, 27, 38.5, 52, 16.5, 85. Now if I add all of them, I will get 303, and that's the answer. And I'm pretty sure that this is not the intended way that the contestants would have done. Yeah, basically this is too long to be done in 2 minutes. Yeah, so that's why I want you to suggest me a good solution for this problem. Okay, because this is for sure not the intended one. Yeah. Okay, so Himanshu is there. There have been 15 views till now and 2 likes. That's a good thing. Let's go to next problem, 303. And the other problems are easier. This was the only problem that somehow needed some efforts. Yeah. Now let's solve this problem. Problem solving. Okay, so first of all we have 1 plus cot square theta, and we know that that's just cosec square theta. So that's why we will have e to the power minus x by sine theta over here, sine of r cos e to the power minus x dx. Now as long as the value of r cos is lying between 0 to 1, yeah, so basically over here it will go from 1 to 1 by e, and these values definitely lie in between 0 to 1. So if the values are lying between 0 to 1, we can basically use the thing that this is 1 minus x square. Yeah, so sine of r cos of theta is root under 1 minus theta square. We can use that. 0 to 1 e to the power minus x by root under 1 minus e to the power minus 2x dx. Now we make a substitution that y equals to e to the power minus x, and that will solve the problem. We have integral going from 0 to 1 by e, and this is just minus dy, yeah, by root under 1 minus y square. Now this is an easy problem. This is just minus of sine inverse y going from 0 to 1 by e. That's why we have minus sine inverse 1 by e plus 0, and this should be the answer, or is it not? Okay, so basically this value over here is just 1. I'm sorry for that, because e to the power 0 is 1. That's why 1, and so plus pi by 2. So pi by 2 minus sine inverse 1 by e. That's the answer. Let's check. Pi by 2 minus sine inverse 1 by e. Okay, let's go to next problem. This problem is also a nice problem, but not as tough as the problem 10. Yeah. Basically, MIT interest me problems are not that hard till you go to the finals. Even in the final, the problem 5 was somehow hard, others were really easy. But yeah, they were long. Yeah, problem 3 was really long, I think. There must be some alternatives, or else that was too long for the participants to do. Now if I let this whole thing as y, we will get 1 plus. Now the whole thing is same as this thing. Yeah, that's why we will have 1 plus y by x plus y. We will first try to find the y. What is y actually? Because we will not be able to deal with the infinite things. That's why we will have xy plus y square is equals to 1 plus y. Next we will have y square plus xy minus y minus 1 equals to 0. Y square plus y times x minus 1 minus 1 equals to 0. That's why we will have y equals to minus b plus minus, but no need to consider minus because that value should be a positive value. Yeah, this value should be positive value. That's why no need to consider negative sign. Plus root under b square is x square minus 2x plus 1. B square minus 4 c by 2a. This formula is long, but it's somehow helpful as well. Yeah, I can write this as this thing itself because that will be helpful later on. Yeah, let me not change it. Now we have to integrate this. Yeah, integrate this from 1 to 3. Integral from 1 to 3 of 1 minus x by 2 plus root under x minus 1 whole square plus 4 plus 2 square by 2. Yeah, and dx. Now we can take 1 by 2 out, and then this will be ln of 1 minus x by minus 1. Is that okay? But if it's that, how do I find, like, if it's that, like, how do I input the 1 over there? Let me see. Oh, why did I do ln? Okay, this is 1 minus x whole square by 2 times minus 1 plus, now for that we do have a standard formula, yeah, which is x by 2 root under x square plus a square by 2, and then ln of sorry, not that, ln of x plus root under, not, this is not the x though, x is x minus 1 actually, x plus root under x. Yeah, and this is from 1 to 3. Now I think you can evaluate this yourself. When there's 1 we have 4 by minus 2. Sorry, when there's 3 we have 4 by minus 2 plus 2 by 2 into ln of 2 square plus 2 square plus ln of 2 plus root under 2 square plus 2 square. Yeah, and then when there's 1, the first thing is 0, second thing is 0, and the last thing is okay. So basically a square by 2. Yeah, okay. So did I miss something? Okay, no, I have not, I guess. But why does it look like I have? A square by 2. Okay, this is a square by 2. Yeah, but why don't I? Okay, is this not x by 2 root under x square plus a square plus a square by 2 ln of is this not the formula, or did I forget the formula? Okay, let me check the answer first to this problem, because according to the answer in my copy, wait, let me check the formula. Okay, let us derive the formula. Let us not check, let us derive the formula by ourselves, because I thought this was the formula till the date, but in my copy I haven't really done that. Let me do. So we have integral of root under x square plus y squared a squared dx. Yeah. Now for this one, how can we proceed? I think I can basically use integration by parts. So root under x square plus a square. Yeah. And over here there's 1, so that's x minus integral of derivative of this is 1 by 2 root x square plus a square, and then we have 2x. Yeah, and we also have x dx. So we have I equals to x root x square plus a square, and then minus 2 cancels out, so we can basically introduce x square plus a square and minus a square by root under x square plus a square dx. Yeah, so we have I equals to x root x square plus a square, this will be minus I plus a square integral of 1 by root under x square plus y a square dx. So basically I do have the a square, like I think I made a mistake in my copy. Yeah, because now this is a square, and this is ln of x plus root x square plus a square. Yeah, and now I can take the 2 down, so that we have x by 2 root under x square plus a square by 2 ln of x plus root x square plus a square plus c. Yeah, this is the formula. Yeah, now let us solve these integrals. So basically I'm doing correct. I think both of the ideas give the same answer, but that's why accidentally, even though I haven't put a square by 2 in my copy, that worked, but I should be putting that. Yeah, now if this is wrong, let us do yeah, because I was just trying to do it directly. Now we have 2 square by minus 2 plus that is 2 by 2 root under 4. Is it 4? Not 4. This is 2 square plus 2 square 8. It's 2 square plus 2 square by 2. This is ln of 2 plus the under 2 square plus 2 square. Yeah, and then minus, if you substitute 1, this is 0 plus 0 plus this is 2 square by 2 ln of 0 plus 2. Yeah, ln of 2, isn't it? Yeah. Now let us see how this goes. Oh, now I finally noticed it. Like in my copy, like I did just to make the answer correct. Like I did not really solve it properly. Now 1 by 2. Okay, now if we divide by 1 by 2, what do we get? We basically get over here -1. Over here we will have this as 2 root 2, so that's why we will have root 2, and this will just cancel out, so we have ln of 2 plus 2 root 2 and minus, that's why we will have -1 plus root 2 plus ln of 1 plus root 2. That will be the answer. Let us check the answer. Yeah, this guy is so dedicated, no one will find even if you do a mistake. Yeah, nice. Okay, let's go to next problem. Now for this problem, okay, how do you solve this problem? So basically you have to notice something. If you expand this expression over here, we will get 1 plus x square minus 2x. Yeah, now what you can notice is, if you basically this basically will just cancel, and this one is just derivative, so it's a lot easier for us to solve now, because we have 2x by 1 plus x square minus this is just 4x square by 1 plus x square dx. Yeah, now this is just derivative, so that's why we can have ln of 1 plus x square minus 4 integral of, we can make this as x square plus 1 minus 1. Yeah, so we have 1 plus x square dx. Now what do we get? This is ln of 1 plus x square, this is minus 4x plus 4 tan inverse x plus c, and that is the answer. And we are basically given the limits of integration as well, from 0 to 1. So this is from 0 to 1, so we will have ln of 2 minus 4 plus 4 times, this is pi by 4, minus at 0, this is ln 1 is 0, this is also 0, this is also 0. That's why we finally have the answer now, and the answer is okay, so did I do any mistake? Again, the answer does not really match. What is the case? I don't really think I made a mistake. Okay, I found it. Even after cancellation, like, why am I writing 1 plus x square over here? This is absolute mess. Now, so that's why we will just have x square over here. Now the same mistake is done in copy, and like I'm really surprised, like how can I repeat the same mistake? Basically my thought process, like at that time and now it's the same, I guess. So that's why. And this is 1 minus 4. Okay, now it's fine, and this is just pi, this is minus 3, and that's the answer. Let us check pi minus 3. Yeah. Oh, big fan, sir. So, okay, I'm also your fan. Let's go to the next problem. So let's do this problem together. This one is a pretty interesting problem. Yeah, let us solve this problem. Okay, so for this problem what we can do is we can first break this into products. Yeah, over here we have e to the power x to the power 3. Yeah, now if we just let y as e to the power x, this problem will be simplified a lot. Let us see how. E to the power y and then y cube. Yeah, now since ln of y is just x, our dx will be 1 by y dy. Now you see it's just some integration by parts, and then this problem will be solved easily. Now we can use integration by parts. Basically we can also use di method. Yeah, and from di method what we can do is we can basically what we can do is you can basically keep the first term and then integrate this one. Yeah, e to the power y. Now differentiate this term to y and integrate this one e to the power y. Differentiate this one to integrate this one e to the power y. And now if I differentiate again, this will just be 0, so it doesn't matter, no need to do it again. Now keep the alternating signs, minus, plus, and a plus c, and this can be just to that y is e to the power x. So we will have e to the power 2x times e to the power x minus 2 times e to the power x e to the power x plus 2 times e to the power x plus c. Now we can keep this term as it is as a common, and we will have e to the power 2x minus 2 times e to the power x plus 2 plus c. Let us check if that's the answer given by MIT integration by team or not. Yeah, that is the answer. E to the power x e to the power 2x minus 2 e to the power x plus 2. Did you enjoy this integral? I think you have. Yeah. Okay, let's go to the next problem then. Now the next problem is something like this. Let me see if he responded or not. Okay, so I think he is gone now, but no problem, we will keep solving because solving is our aim. Yeah, problem solving. Okay, now for this problem, basically since there is a modulus of x, this can be told as even function. Yeah, that's why we can write this integral as since this is in symmetric domain from minus a to a, if there's even function over here, we can write this as 2 times integral from 0 to a of a even function. Yeah, that's why we have 2 times integral from 0 to root 3 by 2 times 1 minus x by root 3 dx. Now after this is just a piece of cake. Yeah, we can take wait a second. Okay, now fine, 4 times integral from, okay, no need to write the integral from again, I can just integrate it directly, x minus x square by 2 root 3. Yeah, integral going from 0 to root 3 by 2. So if I evaluate this, we have 4 times root 3 by 2 minus this is 3 by 4 times 2 root 3. Yeah, minus 0 minus 0. So I guess we have the answer now. Yeah, the answer is root 3 2 root 3 minus 3 by 2 root 3. Yeah, let us see if the answer is correct or not. Okay, so basically there is a modification, so let us see how we can get that. Basically this is 2 root 3 minus root 3 by 2. Yeah, that's why we can write this as 4 minus 1 is 3 root 3 by 2. I think this was the answer given over there, 3 root 3 by 2. Is that? Yeah, me not understand English. because my English is poor, yeah. Okay, now let's go to the next problem. But it's only the matter of solutions. Like, you don't need to understand the language though. You can basically just take the solution, the numbers and the letters, yeah, and that is enough for solving the problem. Now let's check how do we solve this problem. So basically you can also use integration by parts for this problem as well, because if we differentiate this and integrate this, there will be somehow a simpler function. That's why log of 1 plus x square, and the integral of the x1 by x square is x to the power minus 1 by minus 1 minus integral from, the derivative of this function is 1 by 1 plus x square, and then 2x, and the integral of this is x to the power minus 1 by minus 1 dx. Yeah. Okay, sorry. Now this problem has become a lot easier, because now we have minus log of 1 plus x square by x, and minus minus will be plus, 2 times x and x to the power minus 1 will cancel out, so we have 1 by 1 plus x square dx. And now you see that this is such an easy problem. So minus log of 1 plus x square by x plus 2 times, this is tan inverse x plus c. And yeah, I think this is the solution. Let's check if it's correct or not. Minus log 1 plus x square by x, yeah, and plus 2 tan inverse x. Yeah, that's the solution. Yeah. Okay, so hope you guys are enjoying the solution. Let's go to the next problem now. Okay, so this problem is also of integration by parts. Yeah, basically I can know that from the fact that this can be integrated easily without changing its form from 2 to the power x, and this can be differentiated. That's why I knew at the first sight that we have to use integration by parts. Let's solve this problem now. 2 to the power x and then x square. So what do we do is, we first write the thing that's to be differentiated as it is, integrate the other one, 2 to the power x by ln of 2. Yeah, differentiate this, 2x, integrate this, 2 to the power x by ln of 2 whole square. Yeah, differentiate this, 2, integrate this, 2 to the power x by ln of 2 whole cube. And now we can differentiate this since it's a constant and it will go to 0. Add minus plus, and that is the answer. Now one thing you can do to make this look simpler is to take common. Let me see if answer is okay, so the answer also has that thing. That's why let us take 2 to the power x by ln of 2 common, and then we will have x square ln of 2 whole square, yeah, and then minus 2x ln of 2 plus 2, and that is the answer. Let us check the answer from MIT integration B. X square ln square t minus 2x ln 2 plus 2. Yeah, that is the answer. Let's go to the next problem now, and we have 3 more problems to complete all of these problems. We have just 3 more and we will finish it. Okay, now for this one, let us try to first take x to the power 4 common out, and let us see what do we get. If we take x to the power 4 common, we will just have x square over here, and then x to the power 4 minus x square plus 1. Is that? Yeah. And now after that we will have 1 plus x square. Now I think you can notice something over here. This is a plus b, a square minus a plus b square. So that's why we will have a cube plus b cube. So we will have x to the power 6 plus 1 dx. Now what we can notice is, if you just let y as x cube, you will get dy by 3 as x square dx. Yeah, that's why we can make that substitution. Limits will remain unchanged, and x square dx will be used to make it dy by 3. Over here we will have 1 plus y square, and now this is a pretty easy problem. Yeah, now this is a pretty easy problem. Y by 2 root under 1 plus y square plus a square by 2 ln of y plus root under y square plus 1. And all of this is going from 0 to 1. That's why we will have 1 by 3. This is 1 by 2 root 2 plus 1 by 2 ln of 1 plus root 2. And minus, this will be 0, this will also be 0. So I think this is the answer. Now what we can do is just take the 1 by 2 out as common, and we get 1 by 6 root 2 plus ln of 1 plus root 2. And this is the answer. Let's check the answer from the MIT Integration Bee team. 1 by 6 root 2 plus ln of 1 plus root 2. That's the answer. Wow. Okay, thanks for the compliment, and hope you are also enjoying these integrals. Yeah, and you can also share your thought process and your solutions if you want to, and that will make us make our life more interactive. Yeah. Now let's go to the next problem. Okay, this problem is pretty fascinating one, because at first this looks to be somewhat difficult, but after a substitution this will be too easy. So what you can notice is this over here is actually the derivative of x e to the power x. Yeah, and this over here is also the square of x e to the power x. So what does that tell you? So basically we have d x e to the power x by x e to the power x whole square plus 1. Yeah, and x to the power x is actually going in these things. Yeah, basically now what we can do is, this is the standard formula of tan inverse of x e to the power x from 1 to infinity. Now at infinity this will go, all of this will go to infinity, so that's why we will have just pi by 2 minus at 1 this will be tan inverse e. Yeah, now I think that's the answer. This was somehow an easy problem, but we need to make that observation and then it will be easier. Let us see if this is correct or not. Pi by 2 minus tan inverse e. Oh, was it wrong? Okay, basically here's a minus sign. Yeah, and how did I write there plus sign? Okay, I'm sorry for that. Here's a minus sign though, so that's why I made a mistake. Yeah, okay, fine. Okay, now this is minus 1. Now what is the formula for 1 by x square minus 1? We know that is 1 by 2a ln of x minus 1 by x plus 1, and this is from 1 to infinity. Now 1 by 2 at infinity, this is infinity by infinity, and basically if you take limit, that will just be 1 minus at 1, this is e minus 1 by e plus 1. Yeah, now ln of 1 is just 0. You can use the minus sign to take numerator to downside and denominator to upside. That means just to reciprocate the fraction. So 1 by 2 ln of e plus 1 by e minus 1, and this is the answer. Let's check the answer. 1 by 2 ln of e plus 1 by e minus 1. Yeah. Okay, now let's go to next problem. This is the last problem, and this is the pretty interesting problem because this involves gamma function. Yeah, it involves the definition of gamma function. That's why it's a pretty interesting problem, to be honest. Now basically, if you don't know about gamma function, like I will tell in introduction to it, and that will be sufficient. So basically, gamma function is a x minus 1 factorial. Okay, and this gamma function, basically the factorial is for integers, and the gamma function is for all real numbers. For x being integer, this can be made as the definition, but if x is any other real number, we can basically use this integral e to the power minus x, sorry, e to the power minus t, let me write, e to the power minus t, t to the power x minus 1 dt. We can use this integral for other real numbers. Yeah, so basically this can be broken as 80 times integral from 0 to infinity of e to the power minus x, x cube. Yeah, minus 60 times integral from 0 to infinity e to the power minus x, x to the power 4, plus 14 times integral from 0 to infinity e to the power minus x, x to the power 5, and minus of integral from 0 to infinity e to the power minus x, x to the power 6. Yeah, and also add a dx, dx over here, dx over here, dx over here. Now this is 80 times gamma 4 minus 60 times gamma 5 plus 14 times gamma 6 minus gamma 7. Now since these are integrals, you can use the factorial definition as well. That's why we will have 80 times 3 factorial, that is 80 times 6, which is 480, minus 60 times, this is 4 factorial, which is 12, is it? No, 24. 60 times 24, so 0 0, and 24 6, so 24, so they don't have a nice piece. Is this I'm sorry, not this, my bad. So this could yeah, this is the answer. Now 14 times 120, okay, 12 चौक 48 को 8 हाथ लाग्यो 4, 12 का 12 4 16. Okay, now this is okay, 120 into 6 is 720. Okay, now this is 0, 8 8 16 को 7 लगा 1, 7 4 10 11 के 7 लगा 1 2 minus 0, 4 2 6, 7 11 के 7 लगा 1. Okay, we get the same thing. So this is 0. Yeah, though, and most of the time if there are pretty complicated stuffs, answers are 0. Like we also had other problem where the answer was 0, and in this one also we have the answer as 0. Yeah, this is the right answer. And so we complete all the problems from regular season of MIT Integration Bee 2024. We have already done the qualifier, regular season, and now it's the turn for quarterfinals. And in my next video, maybe tomorrow or day after tomorrow, we will be there with the quarterfinals of MIT Integration Bee 2024. Hope to see you there as well. Yeah, hope you guys enjoyed this video, and if you are doing integrals, learning integrals, I do hope that this video will be helpful for you. And yeah, do share with your friends too, like who are trying to learn, and yeah, make this world a better place. Yeah, thanks for watching.